Today's kit build is assisted by Return to Helios Milk Stout from Fort Garry Brewing in Winnipeg. And their tasting notes include roasted coffee, dark chocolate, and a light sweetness from the lactose in it. Sounds like an interesting beer for this. So it's been several months since I've done a kit build. I always do a bunch of them in December. And I figured I would just do one just to chill out and enjoy myself today. So I reached into my box of kits and found this one that I could not remember what it was when I ordered it or what it was supposed to be. So I will do that tonight. It looks nice and simple based on the schematic. We have 3 NPN transistors driving 3 clusters of 6 LEDs each, and some capacitors in between them. What is going on here? So when this one gets pulled low, that one charges. Okay, so basically just the capacitors create a time delay between the turning on of each. That is nice and simple and should make for a very mellow kit build. It looks like I ordered this one anticipating doing it for Valentine's Day, but then I forgot about it, I guess. All right, well, better late than never, I suppose. As usual, I will be using my my favorite board holder. I've tried a whole bunch of them, and this is just the one that I settled on. It works really nicely for any size of board, or most sizes of boards anyways. Yeah, that's a nice looking board, as cheap boards go, you know. Since this kit doesn't really have any instructions, it just has the schematic, I will follow my usual pattern of doing things, which is to put in the lowest profile, least likely to be damaged by my stupidity components first, which is almost always the resistors. Then probably the switch, and then capacitors, followed by the transistors, and then the LEDs, or the LEDs and the transistors, depending on which one is less likely to get in my way. So it looks like there are 2 different values of resistor. There's 300 ohm ones and 3 4.7K. And the kit comes with 2 clusters of 3 resistors each. And if I wasn't colorblind, I could tell you what the value of them is just by looking at them. But since I am colorblind, I will use the meter to tell me. These ones are the 4.7K. So let's start with those. Like a lot of the reasonably decent kits, they've actually got the component values marked directly on the board, which is nice. They've also got designators. For instance, that 4.7K there is R5, which is this one right here. I like having both references available, even though once you lose the schematic, or if you don't happen to have it, which also happens on a lot of these cheap kits, then the component designation doesn't matter, but having the value screen printed on the board certainly does make things easier. So the only reason I bend the leads over on the back of the board is just to hold them in place when I flip it over so that they don't fall out on me. You could hold it other ways, and I will probably hold some components in other ways later on in this kit. I guess we should double check just to make sure that the other resistors that they sent are in fact the 100 ohm as they're supposed to be, and yes, they are. That doesn't happen very often, but it only takes once to really mess up your day. Yeah, that board is taking solder quite nicely. I'm impressed. Nice shiny pads. Well done, whoever made this kit. Next, I think I will put in the switch, which is just a single pole double throw switch, but I'm guessing that they're only using one side of it. Oh, I guess we can check. Yeah, they're only using one side of it, so the pole on the opposite side just isn't used, so that's the off position. Cool. For this, I am just going to bend the outside legs just a little bit, and they are connected to the shell anyway, so they are intended as mounting pins. But even with bending them, I will still hold it in while I'm soldering those mounting pins down. And they take a fair bit of heat because they are connected to that large, well, relatively large chunk of metal that is the frame of the switch there. So it sucks away a lot of heat from your soldering iron. The electrical contacts, on the other hand, don't pull a lot of heat and they solder quite quickly. I'm just going to add a little bit more solder to those mounting pads just to make it nice and secure. It's a lot more blobby than you want an electrical connection, but that's fine. They're not electrical connections. Now then, I think I'm going to switch this around how the board is being held, just to get the grippers taking up a little bit less space on the board so that I'm not interfering with myself. Kind of like that. So I will put in the capacitors next. I think I'll leave the transistors for last because, as you can see, the board holder is kind of interfering with those. So I think, yeah, I will carry on with capacitors. According to this, they are all 47 microfarad electrolytics. Being electrolytics, they are a polarized component. The negative lead is indicated on the package there, but also the positive lead is the longer one. And that matters because if you put them in backwards, they have this bad habit of exploding in certain applications. I'm not sure whether they would in this one, because they have current limiting resistors in between the positive voltage and the negative voltage, or at least they get switched to the negative voltage through the transistor, so they're not going to have a lot of current through them. So if you put them backwards in this application, there's pretty good odds that they won't explode. But why would you take that chance? On the board, the positive is marked with a positive sign, and the shaded area is the negative. So it just makes it nice and easy to keep it straight. The one downside about flipping the grabbers like that is that they get you a lot further away from the board sometimes when you have to work around them. This isn't a super busy board, so it's not that bad to work around, but there are some times when your tools can get in your way. So next is all the LEDs, and they are also a polarized component. There's a couple of different indicators on them. One side has a little flat on the package, which is this side here, which is the negative. And that's also the shorter lead. The longer lead is the positive, just like the capacitors. And on the board, they have a positive and negative marked out. So I'll just drop these in here. I think I'm going to do maybe half of them at a time, just so that the forest of component leads doesn't get in my way. Oh, these ones are oriented to the positive to the top side. These ones are oriented to the positive to the negative side. So always pay close attention. He said, probably failing somewhere in this kit build to pay attention because I'm too busy talking to you guys and not paying attention to what I'm doing. But I hope this time not to fall into that trap. We shall see. Place your bets in the comments below. Now then, I could leave these LEDs spaced up off the board a little bit. That one's bent, so I'm going to straighten it out. Or I could slam them right down flush. And I think that's what I'm going to do because it makes it easier for me to make them all uniform. And of course, I'm going to give the leads a bit of a bend so that they don't fall out of the board while I'm doing this. And another trick that I've picked up over the years for components that you want to be in a nice orientation is to only solder one leg of them initially. And then flip the board over and get everything aligned so that it all looks nice and happy. Make sure that they didn't slip. Some of them did. You see that guy back there slipped, so I'll push down on it, reheat it, melt the solder, let it cool, And there it is. This one's another one that needs a little bit of an adjustment. And that one, I'll just go through and get them all visually where they need to be. Nice and flush to the board. And then we'll continue on and solder the other pad. And of course, clean up the forest of leads to make room for doing the second half of the LEDs. And I didn't pick the ones that I did in any particular order. They're just alternating to keep them out of the way of the next operation here. Because if I had them all in at the same time, then all the leads would get in my way on the back side while I'm trying to solder, and it would just make this less of a fun experience. And the whole point of doing this is to enjoy tinkering around and playing with my hobby here, which is really the entire point of this entire channel. I just happened to bring you guys along for the ride, and you know, some of you seem to enjoy it and keep coming back, so that is just a bonus. And same as before, solder one leg of each LED. Reflow any of them that need to be seated better, and then solder down the second pin of each one. You see how even with only half of the LEDs on, the wires are still kind of getting in my way a little bit? Imagine if they were all on there simultaneously at full length. And then a quick haircut. I'm not being too careful. If it was super delicate components, you might want to take a little bit more time and do them one at a time, but these LEDs are fairly robust, and I don't think I'm going to break anything by doing this. I'm sure somebody is going to have a difference of opinion, and they can feel free to comment down below. Right, all that's left is the 3 transistors. According to the schematic, they are NPN transistors. I'm just going to give them a quick test just to make sure that I didn't get completely dud ones or anything like that. I doubt I will, but yeah, why not? Yep, just a basic NPN transistor, 0.7 volt base emitter junction, which is completely typical. Same again. And same again, within the margin of error anyway. Absolutely close enough. Probably didn't need to do that, but why not since I've got the thing? And if you don't have one of those, you can easily use just a diode test meter on your multimeter and do the same thing. Just massage the leads a little bit here and get them in place. Transistors are, of course, another polarized component, and in order to place them correctly, they have conveniently given us a shape on the silk screen which approximates the shape of the package of these things. So as long as they have done their job right, and I have no reason to assume that they haven't, then this should work just swimmingly, just like that. That one goes this way, and the middle lead, which I believe, if I remember from a few seconds ago, is the base, goes up that way. Come on. This is a bit of a dance getting these in here, but there we go. Let's get them all roughly the same height. Doesn't matter for function, it's just aesthetics. And those leads are bent and springy enough that they are holding everything in place, so I don't have to do any further bending on them. But I will still do one lead at a time and just make sure that they're not knocked too far out of position. No, they look reasonable. And they're not part of the display, so it doesn't really matter other than for artistic points. When it's in operation, it's not going to change anything. I'm going to take it out of the holder for this because that is the last components to go on. And that way the gripper's not in my way. Although, I do need to put some power wires on there. So Let's grab it quickly back in there and deal with that. And for power wires, I'll just grab something out of the box of miscellaneous lengths of wires here. Just salvage wire from random places. And that goes in there. Which one of these should I make the positive? I think I'll make that one the positive. For no apparent reason, just what I want to do. So it is programming 3 volts into my power supply here because that's what it says it wants. It'll probably run on more or less, but might as well give it 3. And I'm going to current limit it down a whole bunch just in case there is a problem or a short circuit so that I don't cook anything initially anyways. And then what did I say for a color code? That's the positive one. That's the negative one. I do like these knockoff Wago connectors. Let's see, turn the power supply on. Okay, there we go. We have flashing. We have 2 of the 3 circuits flashing and one of them is not. Why is that? Why do you suppose? Did I make a mistake? Let's see if we can spot it on the back here. Which one is it? It is that one, that one. Okay, so it's not that one. Let's follow these. It's not that one. Goes over here. Oh, yeah, I'd say that's a problem. But it's an easily fixed problem. Just melt that bridge out of there. Do I need to get extra toolage in here? Yeah, maybe a bit of solder sucker action. There. Now, did that pull too much out? Yeah, it's not beautiful, but it's not shorted anymore either. Does it work now? Oh yeah, there we go. So all 3 of them are flashing. The flash rate is ever so slightly different between the 3 circuits. So the difference in the flash rate between the 3 circuits comes down to the natural variability of the values of the components. The 4.7K resistors are not going to be exactly 4,700.00 ohms. The capacitors are not going to be precisely 47.00 microfarads. So the charging and discharging rate of the 3 capacitors is going to be different. Based on that, the voltage, the base emitter voltage on the 3 transistors is slightly different. It's really close as we saw, but it's slightly different. So all those things combined is going to impact the speed at which the capacitors charge and discharge, which is going to affect the amount of time it takes for the voltage at the base of each of the transistors to get above or below the turn-on threshold, which is 0.6 volts or 0.7 volts between those 2 points. So that's why we have the variance in the flashing rates on all 3 of these circuits. And if we look at just 3 of the LEDs on 3 separate circuits, you'll notice that they are kind of chasing through, and that the on time and off time of the 3 of them is slightly different. D18 in the middle has a shorter on time than the other 2. So it's a neat little circuit, and you could go as many sections as you want with this. You could do with just 2, which would essentially be a flip-flop. You could go 10 or 50 or 100 or whatever you wanted, and it would just keep rippling through just like that. Fun little circuit, nice beginner-friendly circuit. If you are getting into electronics and just starting off, absolutely take a screenshot of that and throw it onto a breadboard and play with it. I assure you that you will have fun with it. Optionally, you could just go and try and track down this kit. I will see if I can find it and put a link down below if I find it. Otherwise, as I said, it is a very simple schematic. You don't need all of the LEDs. You could just do it with 1 LED per transistor. Then you would realistically have just 2 resistors, 1 capacitor, 1 transistor, and 1 LED per section. And as I said, you can go as many sections as you want. I hope you found that interesting. I certainly found it amusing and relaxing, and even a very easy little troubleshoot. Thanks for watching. Questions and comments down below. I'll talk to you later.